Welcome to BKW Physics. My name is Mr. McConley, and I want to take a moment today to show you how to use our next equation on the physics reference table. The equation is D equals VIT plus 1/2 AT squared. And in this equation, D represents distance. Distance, of course, is in meters. We have the initial velocity in meters per second, how fast the object you're speaking about is initially traveling. We have time in seconds, and that appears in two locations, and in the second location it's squared. And finally, we have acceleration, which we have spoken about as being in meters per second squared. So I want to walk you through two examples here today. And the first one is this one right here, out of this book, number 13. It says a race car is traveling at 44 meters per second. It's accelerated to a velocity of 22, and it takes 11 seconds. What is the displacement? Okay, so first of all, I always pick out my givens. And the velocity of 44 meters per second is an initial velocity because it's what, at the beginning of the situation, it's what's happening. And then it says it's uniformly accelerated to a velocity of 22 meters per second. So that's my final velocity. That takes 11 seconds. And the question is asking, so what's the distance? What's the displacement? Now, I just showed you this equation, but at a glance, these variables don't fit directly into that equation. So here's what you got to do. It's actually going to be a two-step approach. Step one, let's find the acceleration. What actually is the acceleration? So acceleration is final velocity, 22, minus initial velocity, 44, over a time of 11 seconds. When I work that out, it's going to give me, because of the order of these, it's going to give me a -2 meter per second squared acceleration. Okay, that's good. What do we do with that? Well, what we want to do with that is we want to go back. So this is step A, we'll say. Step B would be, let's go back and plug that into our new equation, D equals VIT plus 1/2 AT squared, where our initial velocity is 44 meters per second. Our time is 11 seconds. And our acceleration we just found was a -2 meters per second squared. And our time again is 11 seconds squared. So you're going to see we have a negative here, we have a positive here. And as you work through the numbers, it's going to give you a 484 meter, because the seconds cancel out, boom, boom, meters on this side, plus a negative 121 meters on that side. When you do the magic of math, it's going to come out to be 363 meters, which is what they were looking for in this case. So this problem, a little tricky, that's why I picked it out, requires you to take two steps to get to your final answer of what is the displacement. My second example, take a moment to erase these here. My second example appears a couple pages later. And we'll look at number 20 here. So on number 20, you got a bicycle passes a lamp post at 4.5 meters per second. She accelerates down at a constant rate of 0.4 meters per second squared for 12 seconds. How far does she move during this time? Okay, so again, I'm going to jot down my givens. I got that the biker passes the lamppost initially. She's going 4.5 meters per second. She accelerates at 0.4 meters per second squared. This occurs for a time of 12 seconds. And we want to know how far has she gone. Now this problem seems easier, and in fact is, because we can go directly to our new equation, d equals VIT plus 1/2 AT squared, and we can plug right in 4.5 meters per second, 12 seconds, plus 1/2, 0.4 meters per second squared, and a time of 12 seconds squared. Now, what most new physics students do is they forget to square this. It's really key. You got to square that. Then multiply it by these two things. Get what you have on this side, get what you have on this side, and add them together. The bottom line is, when all is said and done, I think the numbers play out something like this. This would be somewhere around a 54. This is somewhere around 28.8. You add them together, and you're going to get about an 83 meter distance. Those are two key problems that both address the new equation that you're dealing with. Distance is VIT plus 1/2 AT squared. Some key things to remember. Read the problem, underlining or circling your givens, your information. Write those givens down, then decide what equations are best suited for solving the problem. Physics.